Lambda, the strength of the penalty, is a hyperparameter. Now, if you have L1 plus L2 regularization, you will have lambda 1 and lambda 2. There are two hyperparameters, and they have to be optimized in the validation set. How do you optimize them? You may want to make sure that the variance is lowest. You want to select the lambda so that the variance, which is the error in the predictive accuracy, is the lowest at that particular value of lambda in the validation set. And here is where I want to graphically illustrate the difference between validation and cross-validation. Because again, if you use validation, you're losing a lot of data. You're underutilizing your data. So cross-validation is the way to deal with that, to reduce the loss of data. So cross-validation, but in cross-validation, you divide the training set into K parts. Some people call it K-fold, F-O-L-D. They typically call it fold. And you train a model I on all but the I's part, and compute the accuracy on predicting the data in the I's part. And then you compute the average of accuracy across all I equals 1 to K. And you want to maximize your hyperparameter lambda by varying it so that you will maximize this average accuracy. So the graphics is this way. This whole rectangle represents the entire training set, and you divide it into 1 to K folds. And for the I fold, you use the rest of it as training data, and you reserve the I section as the out-of-sample test, and you compute the accuracy only on this sample. And then I can go from 1 to K itself. So you have, if K is 10-fold, if K is 10, you get 10 different models. You will train 10 different models, each one with a slightly different training set and a different out-of-sample set. And naturally, you will get 10 different accuracy because you have 10 different models, and you average the accuracy, and then you can vary the hyperparameter to find out when you can maximize this average